Alright, let's use the asymptotes and intercepts to make a quick sketch of the function f of x is equal to x minus 2 divided by x plus 4, and describe the symmetry in the graph if there is any, and also determine the intervals of increase and decrease for f. Okay, so let's take a look at our function f of x is equal to x minus 2 over x plus 4. I'm just going to write down the domain and the range first. The domain here, x belongs to all real numbers. X cannot equal negative 4, right? Because then the denominator would have a restriction. This is a plus 4, by the way, right? I'm just going to rewrite that. Okay, and when you have a restriction on the domain, this implies a vertical asymptote. So the vertical asymptote occurs at negative 4. Okay, so vertical asymptotes are the restriction on the domain. The range here, y belongs to all real numbers, y cannot equal, and because our function is a rational function and it's in the form of axn plus c over bxn plus d, and the degree of the expression on the numerator and the degree of the expression on the denominator are the same, then the horizontal asymptote, let's write HA here, the horizontal asymptote occurs when y is equal to a over b. So this only occurs, you can use this equation when the degree of the numerator and denominator for the expressions are the same, right? So in this case, a over b here is basically there's 1 over 1, right? So y cannot equal 1. So this is your restriction on your range. Your horizontal asymptote is your restriction on your range, and we know that y cannot equal 1, right? Now, to help us out with our sketch, what we're going to do here is we're going to also find intercepts. So I'm going to find the x-intercept. The x-intercept, I'm going to let f of x equals 0. We know that if you want to make a fraction 0, the numerator has to be equal to 0. So all I have to do is equate x minus 2, the factor of the numerator, to 0. X is equal to 2, so our x-intercept is 2 and 0. Okay, now to find our y-intercept, right, we know that the y-intercept is where the graph hits the y-axis. I'm going to let x equal 0. So you're basically doing f of 0, which is 0 minus 2 over 0 plus 4, which is negative 1/2, right? So the point here is 0 and negative 1/2. And now we have our x-intercept or y-intercept. We also have the vertical asymptote and we have the horizontal asymptote. Okay, and now what we're going to do here is we're going to create a sketch, right? So if we're creating a sketch, I'm just going to do that here. Right, so if we're creating a sketch here, I'm going to first plot my x and y intercepts together. I'm going to first plot my vertical and horizontal asymptotes. Right, so I'm going to do the vertical asymptote in red, so x is equal to negative 4. You can use the grid here. Alright, so I'll just do it here. Say this is x is equal to negative 4. And y is equal to positive 1. Let's do that in orange. So this is the horizontal asymptote. Y is equal to 1. Right, and we also have our intercepts. So our intercepts are 2 and 0. So let's say that's here. And negative 0 and negative 1/2. So it should be like, let's say it's like here. This is 0 and negative 1/2. This is just a sketch, by the way. So this is 2 and 0. Right, don't consider this point. And we just follow the confines of our asymptotes. So we know that asymptotes are points of the graph where the graph won't touch but will approach infinity, right? So we can assume here that as we approach the asymptote, as x approaches negative 4 from the right side of the asymptote, y actually will approach infinity. In this case, y approaches negative infinity, right? And I'm going to do the same thing here using the confines of the asymptote. And you can use some test points to actually create an appropriate graph, right? So I'm just going to, but you can see that it'll just basically keep going until it approaches the asymptote, right? And as we approach the asymptote negative 4 from the left side, y will actually approach positive infinity. Okay? Furthermore, as x approaches positive infinity, so as we're going this way, we can see that y actually approaches the horizontal asymptote 1, and it's actually approaching from below. and as x approaches negative infinity as we go this way, y is approaching the horizontal asymptote from above, right? So you can see that with the trace, right? So this is our sketch, and we also want to determine intervals of increase and decrease. So I'm just going to do that here. So an interval of increase, where you'll see basically a positive secant, or positive tangents if you keep drawing it to each point. You can see that there's an interval of increase from negative infinity to the negative 4 mark, right? This would not be inclusive, so x belongs to negative infinity to negative 4. We also have an interval of increase from this end to this end, right? If you draw a secant, it's just this one is an exponential increase. This is more of a progressive increase. The rate of change actually diminishes over time. So union negative 4 and positive infinity. Okay, so both of these intervals are intervals of increase. There are no intervals of decrease here, so not applicable. Okay, if we want to describe symmetry, we can also do the test. I want to test to see if this is actually an odd function. We know this wouldn't be an even function because there is no line of symmetry along the y-axis. So what I'm going to do here is I'm going to do f of negative x. If this is equal to negative f of x, this implies that we have an odd function. Okay, so if I do f of negative x, I get negative x minus 2, negative x plus 4. If I simplify this, this is basically negative x minus 2 over negative x plus 4. If I factor this out, you get x plus 2 over negative x minus 4. Cancels out, right? And you can actually notice here that this isn't an odd function, right? Because negative f of x, which I'll just do out here, let's say we can just kind of erase this portion, right? Like negative f of x is basically negative x minus 2 over x plus 4, which is basically x plus 2 over x plus 4, not x minus 4, right? So you can see that this is not an odd function, and the reason it's not an odd function is because f of negative x does not equal f of negative f of x. Okay, so it's not an odd function, but we did look at the intervals of increase and decrease. Okay, so that's the idea.